We've got another question, actually. So before we move on to this next section, let's just answer this question. And the question is, can you use Windows Azure Connect to connect on-premise to VM roles? If so, what are the limitations compared to a VPN device? Okay, so I'm hoping that most of you can remember that diagram. Let me just find it for you. Up here somewhere. This diagram here. Notice that the thing called Windows Azure Connect is the third connection down, and that's secure machine-to-machine connectivity. That's what Windows Azure Connect is. So, can you use Windows Azure Connect to connect on-premises to VM roles? Yes, you can. Now, the person has used a specific phrase here. They've used the phrase VM role. Now, there is a thing called a VM role, and there's a separate thing called a virtual machine. You can use it to connect to both, actually. It doesn't matter, but there is. I just thought I'd better point out that there is a differentiation between what those two things are. I'm probably not going to. I may do a little bit of a Q&A at the very end and answer what that difference is right at the very end of this presentation. Now, what are the limitations compared to a VPN device? Now, what a VPN device gives you is site-to-site connectivity. So let's imagine I've got an on-premises environment, and let's imagine that there are, I don't know, 1,000 users, 5,000 users there. And then I've got my cloud stuff. So let's imagine I've got SharePoint deployed in the cloud. So I've got 2 domain controllers, 2 SQL servers, and 4 SharePoint servers. So what's that? I've got 9 servers up here. If I want those 1,000 people to connect to this environment internally, inside not going out onto the internet and connecting that way, but to treat it as if it's just a virtual private network, then I would need to put the Windows Azure Connect endpoint software, which gives you a special network adapter, a software network adapter, onto each of those 5 machines, those 5 servers in the cloud, and all 5,000 of my clients that wanted to connect to any of those servers would also need to have that endpoint software installed. So it's quite a big limitation to go through the exercise of installing 5,000 pieces of software onto 5,000, or one piece of software onto 5,000 machines. Now you can see how, every time I bring a new machine online, I've got another install to do. So I've now got a client management problem. It's gone from a network problem to a client management problem. So that's what Azure Connect gives you. Azure Connect is really good when I have a server in the on-premise environment that needs to connect to a server in the Windows Azure environment. Because that's a point-to-point connection, and probably I have groups of users in my environment that connect to that server, and maybe it does a web services call to this thing that's running in the cloud and gets the answer back, and then distributes that to those 5,000 users. It's great for that kind of an environment. It's really, really simple to set up as well. Site-to-site connectivity, what I need in that environment is a VPN device, and I've got my 5,000 users out here connected. They don't need any software on their machines other than the software they use. They don't need any network connectivity software. That VPN device then connects to the 9 servers that are in the cloud, and because what it basically does is it takes this network and it brings it into this network. They're all one in the same network. So I no longer have a client connectivity problem. I just have to worry about having this site connected to this site. So it's much easier to manage in that kind of an environment. I'm hoping that answers the question. If it doesn't, ask another question, and we'll get it in the next break. Okay, let's find where we were in the slides. Got as far as the DIT. So, disks and the DIT, the Windows Active Directory, Windows Azure Active Directory DIT, Directory Information Tree. So, in this diagram, I've got a couple of racks with Windows Azure hypervisors on each of the machines, and I've got a Windows Azure virtual machine. Now, when I deploy a machine, a Windows Azure virtual machine to a rack, I get an operating system disk, and that, in this case, that's a .vhd. But the way that it looks to the system is as if I'm going to a cache, first of all. And I mentioned this earlier, didn't I? I mentioned that, imagine you've got a piece of hardware, USB cable, a cache, a USB cable, and a hard drive. And that if you unplug that whole lot, that's a little bit like unplugging your entire disk. That's essentially what we've got here when we have an operating system disk. The reality is most of this is done in software, but pretend, just for the analogy, that it's like as if it's hardware. It's outside of the control of the operating system. That's the main point. Now, a data disk is a bit different, because a data disk, we go straight to the disk, and 3 copies of the data are held on storage nodes in the Azure data center. So I can do a write to a disk, and as far as the operating system is concerned, as far as the operating system that's running on this thing here is concerned, it's made it all the way to the disk. But it might not have. It might have failed in the cache before the cache got flushed to the disk. Whereas when I write to a data disk, my write goes out through this connection here, all the way through to here, gets written to all of these things, and then an acknowledgement comes back, and the acknowledgement that goes back to the operating system guarantees that the write worked onto the surface of the copies of the disk, well, to at least one of the disks that are out there. There's lazy copying is done after the disks are updated. And that becomes really important when we get to Windows, to running Active Directory domain controllers in the cloud. And the reason for that is because if I put my Active Directory information tree, the DIT, which consists of sysvol and the NTDS files, onto an operating system disk, and you can think about the way that you might do this. You install a virtual machine, you run DC promo, you get to the point where you want to specify a disk, and you just say C:/sysvol, C:\Windows/NTDS, then you could end up with situations where a write occurs to the directory agent, which then does a replication event and also does a write to the local disk. The write may never make it to the local disk because it may make it to the cache. The cache then sends an acknowledgement back, but it never made it to the actual drive itself. But meanwhile, a replication event has kicked off, and we're replicating that data out to our other domain controllers, which are elsewhere in the network. So, okay, so this machine's going to fall down. It falls down, comes back up again. Now I've got a disk with a DIT on it, which is out of date with all the other DITs that are out there. But as far as the operating system is concerned, that last write to the DIT was successful. So I've now got a corrupted directory. So the recommendation is that you do not use operating system disks as the DIT disk in your Active Directory deployments. So you've got a couple of things really to worry about with Active Directory. One is that you've got to make sure that you use a DHCP address and go against best practice. And the other one is that you've got to make sure that you don't use a operating system disk. So remember this slide that I showed you earlier, which said that the operating system disk has a read-write cache by default, and a data disk has no cache. So what can you do in that situation? You could modify it, but there's a reason that the operating system disk has a cache, and that's for speed and performance. So you'll lose some performance if you do that. So the best thing to do is to put your DIT onto a data disk. So I've now got to do DC promo on an Active Directory domain controller takes quite a while because there's a lot of hanging around. So what I've done is I've created a video in which I do exactly this. So let's just watch a full screen video. Takes about 9 minutes, I think, to do an Active Directory domain controller deployment into a Windows Azure virtual network. So let's just have a look at this. Okay, here we are in the portal. We'll go to Networks, and we'll create a new virtual network. And I'll call this one Demo Virtual Network. I'm going to create a new affinity group. It's going to be in the North Europe data center, and I'm going to call this North Europe Data Center Affinity Group, NEDCAG. Okay, I'm now going to create some address spaces. So I'm going to create an address space in the 192.168 range, and you can see that 16 there masks off the top 216 bits. So all addresses within the 192.168.x.y address are this address space. For an AD subnet, or just AD will do. And its address is going to be 192.168.1.0, and we'll mask off the top 24 bits. So there's bits 0 through 23, the top 24 bits. So all nodes within that network are in the AD subnet. Okay, we'll add that one. We could create another one, so let's just create another one. Let's call this one other. And that can be in like 192.168.2.0, and then we'll mask off the top 24 bits to specify the subnet. Okay, so I'm not going to use any DNS servers from any special network because I haven't got a DNS server yet. I will create one myself later. And let's say OK to that. So we're away creating it. So we can see that's created the VNet. Now I need to put a virtual machine into that VNet. So let's go create a virtual machine. Create a virtual machine from the gallery. And we'll create a server 2008 R2 SP1 from August. I'll use server 2008 because I'm sure most people are familiar with server 2008 at the moment. So let's call it AD domain controller. We'll create a password for the administrator account. This is like creating the account. I'll specify I want a medium size virtual machine, and this is going to be a standalone virtual machine, and I'll call this ADDC or ADDC Planky. Oh no, ADDC demo. Look, there you go. .cloudapp.net. I'll automatically generate a storage account to put that file in, and my virtual network is going to be the demo VNet, the one I created earlier, and we'll go forward with that. So I'm not going to worry about an availability set, but you can see here there's the subnet within that virtual network. I'll select that, and we are now provisioning that server. Okay, so we can see that we've created the virtual machine. So let's kill that and let's kill that. It's now stopped, so I'm going to start it. Yes, let's start it. So it's successfully restarted, and it's now in the running state, so let's connect to it. So this is just an RDP file which is being has been downloaded to my desktop, and I'm now connecting to the virtual machine. So I set the password up earlier. So, okay. And here we are on the desktop. Okay, so we can see that this is ADDC. It's in a work group. I'm just going to show you a few things about it. The first thing I'm going to show you is the IP address, which is probably going to be 192.168.1.4. Yes, there it is. Let me just mark that and show you. 192.168.1.4. So we know that we're in the .1 network, and it'll always come out that almost always the first node in a virtual network is the .4 node. Okay, I'm now going to show you in Server Manager the disk setup. So storage, disk management. Okay, so you can see I've got two disks, C and D. I've got a 30 gigabyte NTFS drive for the operating system, and I've got my page file and temporary storage on the D drive. Those are the only two disks you get when you build a system from the portal. Right, so there's my domain controller. If I now go and attach an empty disk, the machine name is that. This is going to create a location for me to save this. I'm going to create the file. I'm going to call it drive F. It's going to be a 20 gigabyte file. Okay, so that's going away now and creating the disk. And we can see it's not quite done yet. Okay, so we've got the disk, and you can see here that's the location of the disk. So that's the data disk. Let's reconnect. Okay, so when we go into the disk management, we can see here is a new disk, and we're going to initialize that disk. And then there's the disk 2, 20 gigabytes. Let's create a new simple volume. It's going to be drive F. NTFS, I'm going to call this AD directory information tree. We'll perform a quick format on it and say yes to that. So we've got our new AD DIT. Let's go and have a look at that disk on the computer. There it is, AD DIT, and it's empty at the moment. So the next thing to do is to run DC promo. So let's do run DC promo. Okay, so let's run through the wizard. We'll create a new forest. It can be called plankitronics.com. We'll make this a 2008 R2 functional level forest. Okay, so we'll install the DNS server. And this is the bit, yes, I will install. I'm going to put a different folder there. F:. And say next. Then my restore password. Everything's okay, so let's wait for it to do its stuff. Okay, so let's finish the installation, and now let's restart the server. Let's see how it's doing. It's in the running state, so let's reconnect. Okay, so let's have a look at that server manager. Okay, so we can see it's addcplankitronics.com. That's the domain, plankitronics.com. We should have the tools, Active Directory users and computers. Let's drill into this domain. Let's go into the users container. And let's create a new user. AD user, AD user. Okay, I'm going to make that user a member of the administrators group just because of the, I'm just going to log them on, and it's, where's the properties gone? There we go, properties, member of, I don't have to give them any special rights for RDP if I make them a member of the AD administrators group. So I should be able to now close all this stuff down. Log off. And let's reconnect. So this time I shall specify Plankytronics /AD user. Okay, so we're successfully logged in. Let's just have a look at a couple of other things. Admin tools, DNS. There's the Active Directory domain controller. Let's look in the forward lookup zones and find this domain controller. There it is, and notice its address 192.168.1.4. However, that address was obtained from a dynamic IP address, not a DHCP address, a dynamic IP address. Let me show you. Obtain an IP address automatically. I should actually set this up correctly as well, shouldn't I? 192.168.1.4. Okay, so we've got our domain controller. Okay, so hopefully that's given you a good view of how you would deploy one or more Active Directory domain controllers into a virtual network to provide services for an infrastructure that you have deployed entirely into the Windows Azure network. And as you saw in the demo, I don't have the hardware to enable me to do it, but we could have connected up to a virtual private network gateway, which would have allowed those services to be viewable on my internal network as well. Right, let's just come out of this. Oh no, I go to the next slide. So there is another service which is called Windows Azure Active Directory, and that it's not what you've just seen. You have just seen, in my case, a single virtual machine being deployed, and then having DC promo run and running Active Directory and DNS on the internal Windows Azure network. You can also get a service called Windows Azure Active Directory. It's not Active Directory as you would know it. It doesn't have an LDAP interface, it doesn't use Kerberos, it's not designed to support existing Windows Azure Active Directory it's not designed to support existing Active Directory integrated applications. It's a directory service that runs in the cloud and can be used to federate with and synchronize with Active Directory in the on-premises environment, but it is an entirely different thing, so don't get the two of them mixed up. If ever you hear anybody talking about Windows Azure Active Directory in the cloud, then clarify with them. Are they talking about Windows Azure domain controllers running in the cloud as virtual machines, or are they talking about this service that you can buy and you can consume? Well, actually, you can't buy it yet because it's still in preview at the moment, but I'm going to show it to you, and there will be a price associated with it at some stage in the future. Okay, so let's just go through, sorry, my apologies. Before we go into this, let's go and have a look back at some of the earlier bits of demo that we were doing and see how they're deploying in the portal. So we had a what did we have in virtual machines? We were deploying a second virtual machine, weren't we? And that was called I had TechDays 12. That's my SharePoint infrastructure. Have some of them disappeared or something? Let me just refresh this because I did create another machine, didn't I? Oh no, I didn't create the other machine because I didn't have enough cores. But I've deleted that that Linux machine, so I should now be able to create one. So let's go through that process. I now create a new virtual machine. Oh, well, I thought that I had created it. Never mind. sorry, create a new virtual machine, compute virtual machine from gallery, server 2008 R2 SP1, and I'll call this one, I've just forgotten what that first one was called. TechDays 12. So do you know, I thought there was one called TechDays 12 VM. Is that the one that failed earlier? Because it didn't have enough cores? Let's try again. Right, so I'll call this one TechDays 12 VM. Connect to an existing machine. I'm going to connect to TechDays 12. I'll use, this is the one, I'm sure this is where I had the problem trying to get onto the Northern Europe network. Here we go, North Europe. And say OK to that. Now on this machine here, I did have a endpoint that was created. There's that HTTP port endpoint, and you can see it says that it's not load balanced. So what I'm waiting for now is for that new virtual machine to be provisioned. So TechDays 12 VM, when that one is provisioned, I will create an endpoint which links that machine and that machine to the same load balancer. And something came up in a camp that I was running a couple of weeks ago, or last week in fact. Let me just show you this one here. When you create a VM and you get to the point it says either you can create a standalone VM or you can connect to an existing VM. It gives you the impression that what you're going to do is you're going to connect to an existing VM. You're not going to do that. What it means is if you have an existing VM, would you like to join this new VM that you're creating onto the same network segment and isolate it from all the other bits of infrastructure that you have? So as you saw, I think I've got 20 cores deployed. I've got probably something like, I don't know, 15 servers, 16 servers, something like that deployed. But what I've just done now is I've joined 2 servers into the same network segment, and they're completely isolated from all the other network segments. So there's no way that I can run any code which can sort of burrow through the network infrastructure and get to any of my other services. If I wanted to do that, I would put either those other services into the same network as this one, or join them all together with one large virtual network. So I can do one or the other. And that's one of the things that happens with Windows Azure's networking to ensure isolation. When I specify an endpoint that's going to be used for internal communication, then if the two resources, the 2 servers, end up on a different subnet, then a router sits between them, and that router will only allow communication. Let's imagine that I specified I wanted communication on port 5051, for example. Then the router would only allow communication into that virtual machine through its router port on port 5051. So that's another way that the whole thing is protected. You know, if you had a 3-tier application which consisted of a website at the front end, a middle tier, and a database at the back end, and somebody managed to find some vulnerability in the website and take control of it, they can still only get access through the various ports which are configured in either in the portal or in the case of a PaaS environment through that service model that I showed you earlier with the you know, those XML files, the CS, CFG, and the CS def files. So there's a lot of protection that's put in place to ensure that things get isolated from each other, and they actually end up on separate VLAN segments so that they don't overlap in any way. Okay, let's just see how that thing is doing. It's probably not deployed yet because it takes about sort of between 6 and 10 minutes, something like that, for a VM to deploy. But let's see how it's doing. It says it's starting provisioning still. I'll just do a refresh in case there's a bit more of an update to its status. Retrieving status still. I'm sure that'll update in a minute. Oh, here we go. It's still running provisioning. Okay. So while we're doing that then, let's go back to the slides. and let's talk about this thing called Windows Azure Active Directory. So remember I said that Windows Azure Active Directory is different to running a domain controller in the cloud. So let's build this. And the way we build it is we can take a server and we can add a database to that server. Not an LDAP database, but we can add a database. I don't know what the database is, but it's kind of irrelevant, because what we then do is we add a REST interface, not a LDAP interface. So Windows Azure Active Directory exposes its services through REST, not through LDAP. And that's a really absolutely core fundamental difference between the two services. We can enable massive scalability. Now, the Windows Azure Active Directory service is going to be deployed in all our data centers and is probably, at the end of its life, going to be used by tens of millions, if not billions, of users. So it is a massively scalable service. It scales out. Multiple instances of it run. You never really see that, though. You never see the instances running. All you do is you connect to an endpoint and you say, that's my Windows Azure Active Directory service. The next thing you do is you take an application and you connect that application up to the REST endpoint. And the sort of things that you can do, you can scale the store to make it fit. That will happen automatically. You don't have to worry about that. You can authenticate. So if you've got a service that you want to, if you've got an application service that you want to use some features of the directory, then you have to have a valid account in order to be able to use the service. And you can pull directories typically contain user data. You can pull user data into your application. That user data tends to be, users, groups. If you take a user, for example, you might want to find out different attributes that they have. First name, last name, telephone number, department, those sorts of things. So what is the problem statement? What is it that Windows Azure Active Directory is trying to address? What problem is it trying to address? And it's basically this. If you have an on-premises application that you move to the cloud, let's imagine that you've got an on-premises expense reporting application, it's Active Directory integrated, and you move it into the cloud. Well, in order to run it in the cloud, it's no longer going to have Active Directory connectivity. In that diagram there, what you can see is an AD behind a purple firewall border, and once you've moved that application outside, you're going to have to do some engineering on the application to make it talk to the inside world. So, for example, you know how a user normally comes into the office in the morning, they do Control-Alt-Delete, username, password, they hit the return button, they're logging in, they probably then go and get a coffee, come and sit down, and then they click a link, and it might be 3 or 4 minutes, 5 minutes maybe, since they've actually done the login. But they click a link and it takes them to that service, it takes them to that application, and they aren't prompted for credentials again. And that's because Active Directory has already authenticated them when they did the Control-Alt-Delete username password. Well, of course, that's not going to work in this environment, because that application is now completely outside of the corporate network. It's completely outside of the firewall. It's not under the influence of any Active Directory anywhere. So if you ran this migration over the weekend, the first clue the user is going to get that something's gone wrong is they go to connect to the application, and this happens. Suddenly, a username and password dialog box pops up where there was none before. They're expected now to use a username and password because you've moved an application to the cloud. It's almost like in fact, this statement comes up. While enterprise is working to consolidate identity system on premises, cloud apps are fragmenting identity again. So that's very true. We've done all of this work, especially around Active Directory and Federation and all of these sorts of things, to end up with fewer and fewer identities inside the firewall. And then we start taking advantage of the economics and the agility of cloud computing, and it's a different story now. Now we are starting to fragment identity again. That is the problem statement. That is the thing that Windows Azure Active Directory is attempting to correct. And how does it do it? Well, this shows that we've got an Active Directory in the middle. The triangle represents the Active Directory with its LDAP hierarchical namespace. And we've got applications which exist in different cloud environments. They could be all the same cloud operator, they could be different cloud operators. But it means that we need separate usernames and passwords, we've got a provisioning problem, and we've got no direct connection to the directory anymore. And so that's a challenge. If we look at the history of Active Directory, this should give us a little bit of a clue about what's happening. So we have this service called Office 365, and that consists of three main services: SharePoint Online, Exchange Online, and Lync Online. And you can see them in this diagram here. So Office 365 is a directory service. You put your users into it. You then assign them licenses, and those licenses allow them to use either SharePoint Online, Exchange Online, or Lync Online. Well, watch. Did you notice? Let me just do that again. If you watch the Office 365 triangle in the middle, it changes to Azure Active Directory. And that's because Active Directory is now being revised to operate as an internet-scale massive identity service, and it was actually built at the same time as the Office 365 directory was built. So the Office 365 directory was built in order to scale up and service the massive needs that Office 365 has. Well, Windows Azure as a directory, or Windows Azure as an application platform, also needs a directory which can scale massively. And so the Office 365 directory was always built at the same time as the Azure directory. It's just that the Office 365 services made it to market before the Azure services did. And so they are one and the same thing. So customers might say, how do I get Azure Active Directory? The first question I need to ask them is, do you already have Office 365? Yes. In that case, you already have Azure Active Directory. I don't have Office 365. Okay, well, you can sign up for an Office 365 tenant and you will get Azure Active Directory, or you can go to the link at the Windows Azure Active Directory portal, the Windows Azure Active Directory announcement. I'll give you that link later on. And you can sign up for Windows Azure Active Directory tenant is what it will be. And what that will allow you to then do is single sign-on across Office 365 and Windows Azure Active Directory applications using your Office 365 credentials, which is actually your Azure Active Directory credentials, because they're the same thing. Okay, so Office 365 and Azure Active Directory, exactly the same thing, and they're looking after the needs of sign-on and security for Office 365 and Azure applications. Active Directory on-premises is different to what's running in the cloud. This is an LDAP directory. This is a directory which exposes a REST interface. This is designed to be, you get access to the management features of this, like, for example, sites and services and subnets and all that kind of stuff, and how you deploy the service, how you configure replication. This one over here, you don't get access to any of the service at all. You can create users, you can create groups and roles and things like that, and put users into them. You can assign licenses. So you can use the service, but you can't manage the service. That is managed by Microsoft. So the two different, Active Directory and Azure Active Directory are two different things. But it does mean, of course, that you can connect up your enterprise applications and your line of business applications. Now, there has to be some kind of linkage between what you have in the on-premises environment and what you have running in the cloud, and there is. So it extends the on-premises Windows Azure Active Directory to the cloud through two technologies, through synchronization and through federation. So you can synchronize the identities that you have in your Windows and your on-premises Active Directory to the Windows Azure Active Directory that you've got running in the cloud. You've actually been able to do this for some time now. Since the directory sync feature of Office 365 was introduced, you've been able to do that. And you can do that now. It uses a modified version of MIIS 2003, Microsoft Identity Integration Server 2003, as the DIRSync engine, which will sync users from the users container into the Azure Active Directory. Okay. One of the other things it does, though, is if you don't have an on-premises Active Directory, then it gives you a way of having single sign-on across all of your application estate and all of your Office 365 estate. So you could have a single entry in your Azure Active Directory, you know, like Planky at plankytronics.com, that would be my kind of choice. And that single user would have a single username, a single password, and they'd be able to log into all of those services. SharePoint Online, Exchange Online, Lync Online, whatever enterprise apps you deploy to the cloud, and whatever line of business apps you deploy to the cloud. Plus, of course, whatever other applications you buy off the shelf that will run in Windows Azure Active Directory, sorry, in Windows Azure, if you buy them via the Windows Azure Marketplace, as an example. Okay, so the relationship is on-premises and Cloud Active Directory managed as one. So the sort of thing that you might do is you might provision your users into the on-premises directory and synchronize them into Active Directory up in the cloud, meaning that nobody gets the ability of using, let's just say, an Office 365 account unless they've got an entry in your own Active Directory. We'll synchronize the systems and we can federate the two systems together, and I'll show you how that works in a few moments. One of the features that the directory has, it doesn't have an LDAP API, but it does have we call it the Graph API. Graph is it's a trendy way of talking about getting hold of user data. How do you get hold of the user graph, the graph of users that are using your system? So the Graph API is a REST API that gives you programmatic access to the directory. So in order to use this, you have to write some code in your applications, and that code will do REST calls into this API, and it will pull back data. And the data comes back in JSON format. So what is used for authentication, though, is a protocol called OAuth 2.0. And in fact, a number of protocols are used. I'll show you what those are in a minute. But in order to get access to the Graph API, use the OAuth 2.0 protocol. So here's an example of a directory graph call. And the good thing about it is it's kind of just about human readable. This is a request. So I'm sure most of you will be able to work out that this is going to do a read of the user object called ed@contoso.com. So the very last bit of that URL there, ed@contoso.com. And ed obviously exists in the user's container, and he exists at a directory called contoso.com, and it's at directory.windows.net. So that would be a request for any information about this user called Ed, and all of the attributes that I have the permission to see would be returned. So let's have a look at what that return looks like. Ooh, it's really messed up, isn't it? I'm going to change that right now to I'm going to put a white background on here. It's obviously got messed up when I've inserted it. Look at this, look. Inline modification of the slides. I bet you don't see that very often. Put white in there. Now all the white stuff's disappeared. Now what I've got to do next is get all of that text, and I'll make it all black. Right, there we go. Let's save that away. Wait for it to save. I'll have a drink while it's saving. Okay, so we can see various things in here. Let's just get the pen up. And so, for example, I can see that his department is operations. I can see his given name is Ed. So you can see the format of this is very simple. It's an attribute, a colon, that bit in the middle there, and then the value of the attribute. And that's basically what it is. We've got, some other bits of little system information in here about which container he's in and what he's a member of. But that's essentially what we're talking about here. So the data format is relatively simple. I mean, I have sort of difficulties with a lot of this because REST tends to be, for a developer, tends to be a lot of string manipulation, string after string after string being concatenated and searched through and so on. But what people tend to do is build libraries that give an object model that sits on top of all that string manipulation, so that you just say, I want to have a property called manager or department or given name, and it just returns that for you. It makes it much simpler. So if we have a look at the anatomy of a typical cloud application, a sort of typical application that you might find deployed into the cloud, it'll look something like this. the account and profile store. So accounts are the places where the usernames and passwords are stored, and the profile is something that gets me access to the data that that account holds. So for instance, if it was an online retailer, it might have my, my list of purchases that I've made. It might have my registered credit cards. It might have my home address, that kind of stuff. That would be my profile, and my account would really be my username and my password. And the two things tend to sort of link together in most cloud applications. And most cloud applications will probably have a web front end, but they might have a web service, and the reason for that is because the range of things that might want to connect to them. So obviously a web browser would connect to a web app, but something like a mobile app, it would be an app. You know, the modern world of apps, Windows 8 apps, iPad apps, iOS apps, Android apps, Windows Phone apps. This is the new world that we live in, and people are tending to move away from web browsers and more towards, specialized applications that are giving those specific functionality. And of course, a server application would probably want to use a web service rather than doing things like screen scraping on a web app. So that's the anatomy of a typical cloud application. And what we would typically do to authenticate is send a username and a password either from our web browser, from our mobile application, or might not be a username and password, but some form of symmetric key maybe from our server application. And what happens is if those things match up in our account and profile store, then what the application does is it sends access granted, and you're allowed to get access to various features of the application. So let me just show you, before we go into the application, let me just show you an example of Windows Azure Active Directory. I'm going to show you a couple of things. Oops, let's discard the ink annotations. So I go to, I need to fire up a private browser because of the credentials. So I'm going to go to Active Directory. There we are, activedirectory.windowsazure.com. And now I've got to use my Office 365 tenant login to get access to this. So it's Planky at plankytronics.onmicrosoft.com. And I'm not telling you the password. So this is Windows Azure Active Directory. Anybody who's got an Office 365 tenant may notice it looks incredibly similar. In fact, it looks exactly the same. So what can I do here? I could look at the users and groups that I've got in this system. So I've got 3 users in here. I've got Planky at plankytronics.onmicrosoft.com. He is the administrator of the system. This person is God. I've got a user called Steve Plank. I've got a user called Manager Plank. In fact, if I go into the Planky Plank account and I look at more details here and go into Exchange Properties, we'll see that there is a linkage between Manager Plank and Planky Plank. So if I go to Organization Settings, and come down here, you can see that my manager is Manager Plank. Okay, so there is like a hierarchy. Well, if you think in a very large directory, there'll be multiple hierarchies. There'll be managers who have managers who have managers. There will be users who are members of roles and groups and so on, and those may be members of groups and so on. So there are many hierarchies existing in the directory. And that's really what the Graph API is aimed at surfacing for you. So you could have an application where you authenticate to the application, and then what the application does is it goes and does a search in the directory, and maybe it finds your manager, as an example. If it finds your manager, then it can do something with that. Maybe an example I'll show you later is an expenses application, so it can route the expenses to your manager. As long as somebody keeps the directory up to date, then it will always find your manager. So if you're in the scenario where you had an on-premises Active Directory, and you were synchronizing those users and their relationships into the Windows Azure Active Directory, and the expenses application was deployed in Windows Azure, the fact that your managers changed would be synchronized to the Azure Active Directory, and that would be discovered by the application when it used the Graph API to find out who your manager was to route the expenses application, to route the expenses. Let's go back to the Active Directory. What else can I do? I can actually specify my own domain. So by default, the domain will have a domain name that you give it, Planketronics, and then .onmicrosoft.com. So yours will be your domain .onmicrosoft.com. On Microsoft is basically online Microsoft. Microsoft Online Services is what that really means. I've actually got I own Planketronics.com, and the domain registrar for that is Melbourne IT. And I've actually got a problem with it at the moment. I'm trying to verify the domain, and I've obviously done something wrong because it just keeps coming back and saying I can't verify the domain. But if I was to get that working, and I'm sure I will do, then my directory would be called Planketronics.com, which I think is a slightly more interesting name than Planketronics.onmicrosoft.com. So I can have multiple domain names if I want to do that. If I want to federate with this domain, then I would use a domain name, and I would set up federation. Federation between my on-premises Active Directory and my Windows Azure Active Directory. Now, one thing I want to point out here, and this is a really, really important and key distinction. I can have a Windows Azure Active Directory either as an Azure Active Directory or as a federated directory. It's one or the other. And the difference between the two is where the credentials are stored for logon. If I have it as an Azure Active Directory, in other words, it's unmanaged, it's its own tenant, then it's called a managed directory. Then the username and password for the accounts that are going to use this system are stored in the directory. If I set that up as a federated directory, it's no longer a managed directory, it's now a federated directory, then the usernames and passwords are stored in the Active Directory, which is federated with Windows Azure Active Directory. Now, what that means is my Active Directory has to be available in order for me to be able to log on to those services. So if the internet goes down, or if my federation service in my on-premises environment goes down, then I can't log on. So that's an important distinction to make. Okay. Okay, so that's really the directory. I've got a few other. I'll just show you a few of the other things that are in here. Services. So these are the services that I'm subscribed to: Exchange, Link, Microsoft Office, Desktop Apps, and SharePoint. That's what you get with Office 365. Users and groups, which I've already shown you. Those are the users. Domains, which I've already shown you. Licensing. So I've got the Microsoft Office 365 plan E3 here, and I've got 25 users, and I've assigned a license to 2 of the existing users that I have. And then integration, and this is how I set up directory sync and how I do single sign-on. Single sign-on makes this into a federated directory. And single sign-on means I will be using single sign-on from my on-premises Active Directory. That's what that actually means. Okay, now there's another service I can use, which is called the Graph API. Where's that gone? Graph Explorer. And this allows me to explore the graph of my directory, to explore the directory that I have through the Graph API. So I need some credentials to log into this, and I've got them here. I need the app principal ID, that one there. I'll log in. And I need the symmetric key. That one there. Okay, that allows me to log in. Okay, so this is what the graph output looks like for that directory that I just showed you. I showed you a really nice UI, but we're now looking at it as raw graph or JSON data out of the REST API. So if this bit here represents the very first user that I'm talking about. You can see here we're using a horrible GUID to represent the user, but if I drill down here a little bit further, we'll see some more stuff about this user. We'll see, for example, his display name is Manager Plank. His given name is Manager. I'll find his surname somewhere. SN, isn't it? No, I can't see it anywhere. His mail name is managerplank@planketronics.onmicrosoft.com. Anything else in here? Nothing else. Oh yeah, his surname is Plank. If I come down here, this represents the next user. So if I come down here, I can see, look for something interesting on this one. There's the given name, Planky, and that is planky at plankytronics.onmicrosoft.com. What else have I got here? If I come down here, this would be the next user, and this should be Steve Plank. So here we go, display name, Steve Plank. So that's just using the Graph API to look at that. If you get access to this tool, it's very easy to find. You can use a demo company. So we've got a demo company here, and if I do get, that will get for me all the different directory objects in here. If I go to the users container, it'll show me all the users that exist in here. And this is just a demo company. This is really, I mean, what this is really designed for is so that you can get used to the Graph APIs. This is not really an explorer that you would use. Okay, in order to get anything deployed into Active Directory, you need to create a service principal, and we'll just cover some slides to show you how that works. Okay, so what I've got in this diagram is an authorized user. In my case, I've got this directory. It's called, up there, in the slide, it's called plankytronics.com. Think of it as plankytronics.onmicrosoft.com, and you see it says there authorized user. That's me, Planky at plankytronics.onmicrosoft.com. What I'm going to do now is log in as that authorized user and create an app principal ID. This is like a service principal name. Are there some questions coming through? Look at this. Look, I've got them all on a Windows 8 tablet. Okay, so we got two questions here. One from David says, could we use a VM in Azure as a backup for the federation services on-premise? And another one says, please can Planky, this is from Mark, please can Planky repeat the point about AD federation, and if AD is down, then can't log on. Right, let's talk about the first one first of all. Could we use a VM in Azure as a backup for the federation services on-premise? For the federation services on-premise. Right, in fact, let me come to that question when I do the federation diagram, and I'll answer that question then. So the other question was, please can Planky repeat the point about AD federation, and if AD is down, then can't log on. Okay, in fact, when I get to the next slide shows federation, so I'll get to both of these questions in the next slide. So just bear with me for a few moments. So this is how the system works. The user creates this thing called an app principal ID, or it's a service principal, which contains a thing called the app principal ID. And then what we do is, that's a one-time setup. And from then, the user will then connect to the web application. The web application will have some federation technology on it, which will redirect it to the login point at Windows Azure Active Directory. The user will then authenticate, and they will get a token. So that's what that token was. Let me show you again. The user authenticates to the directory. In other words, the Azure Active Directory thing says, put your Azure Active Directory username and password in now. You type it in, and this token, it's a SAML token, sorry, it's a JSON token, is created. And that will contain the app principal ID. Now, this token is reusable. So the server application which has now got this token can reuse it to authenticate to an authentication point, and it will then retrieve, or it can then talk to the Graph API and retrieve whatever data it wants. So for example, it might pull back some data which says that, you know, there's a particular an attribute, something like your customer ID, for example. You pull back your customer ID, which means it could then do a lookup into the account and profile store for that customer ID and retrieve all of your past records of all the stuff you've bought in the past and display that on your page. So that's the sort of thing that you might use it for. Now that's using, obviously, that's using stuff which is in Azure Active Directory in order to be able to use the system. But what if you want to use something that's in your own directory? And that's really where federation comes in. So Active Directory Federated Trust is what we're talking about. And what you need for this is your own Active Directory. And in your own Active Directory, you'll have a federation server, an Active Directory Federation server running. At that point, you'll set up a federation trust between Active Directory and the Azure Active Directory. And you'll have your line of business application connected to your Azure Active Directory. So here's the web browser over on the left-hand side. The user connects to the line of business application, which redirects the user to Windows Azure Active Directory, which is federated with Active Directory on-premises and redirects the user to Active Directory in the on-premises environment. Now that's where your username and password is stored. Depending on how this web browser is connected to that directory, depends on what happens next. If that web browser is part of the internal Kerberos infrastructure, it's a domain-joined client, all of that kind of stuff, then the fact that they've logged on earlier in the morning means they're already authenticated. But if they're outside of the network, or if they're not domain-joined, or some other sets of scenarios, then a username and a password prompt or the federation service in Active Directory on-premises is going to prompt for some credentials. So it prompts for some credentials, you type your username and password in, and it will then issue a SAML token. Let me just replay that. It will issue a SAML token, and that SAML token will be sent to the web browser, and the web browser will, or I should say, the federation service, the Active Directory on-premises federation service will post the SAML token through a redirect to the place it came from, which was Azure Active Directory. So that token is going to go like that. Azure Active Directory will crack that token open, and it will check that it was truly issued by the Windows on-premises Active Directory that it thinks it came from. And it can do that because when this trust is set up in the first place, this one here, there's a certificate exchange. So the certificate which was used to sign this, the private key which was used to sign this token, the corresponding public key is used by Azure AD to check that token. So it says, I know it definitely came from my trusted Active Directory. It will then generate its own SAML token and redirect the web browser back to the line of business application. And the line of business application has its own trust, this line here. Let me do that let me highlight it with the pen. This line here is the relying party trust, it's called. So it means that if this token now has been returned from Active Directory, because this thing has the certificate, let's draw a certificate, has the certificate which is got the public key in it, which can be used to check that this is a valid token which was issued by this Azure Active Directory, then the line of business application trusts that token and allows the user into the application. So let's go back to the questions now. So the question was, please can Planky repeat the point about AD federation, and if AD is down, then you can't log on. So I said earlier, let me clear how do I clear that stuff? I'll go off the slide and come back onto it again. Right, oh, it's still there. There's a way of clearing that, I don't know what it is. Is it C? No. Somebody did tell me what it was earlier, actually. I bet there's loads of people online who know exactly how to do this, and you're saying, why don't you press the something button? But I don't know what the something button is. Okay, well, I'll stick with this. I said earlier that this Azure Active Directory service is either federated, F, or managed. It's one or the other. If it's federated, then the only place you can be authenticated is down here in the on-premises Active Directory. What does that mean? Well, it means if this on-premises directory is offline for some reason, doesn't matter what the reason is, if it's offline, then you can't log on to that application, to that line of business application. Okay, that's quite an important point. So if this machine, for some reason, can't get access to that directory there, then they're not going to be able to log on to that application. So that's quite an important point. If this directory is managed, then you can't use your federated directory to access that application. You can only use usernames and passwords against user objects which are stored in the Windows Azure Active Directory. So it's one or the other. You can't sort of say, oh, I want, you know, this bunch of users to be using on-premises directory and this bunch of users to be using the managed directory. You're either the entire directory is federated or the entire directory is not federated. It's one or the other. So that question, please can Planky repeat the point about AD federation, and if AD is down then you can't log on. That's true. In the same way that if AD is down in your on-premises environment, you can't log on. If it's down in a federated environment, then you can't log on. And then David said, could we use a VM in Azure as a backup for the federation services on-premise? You know, that's actually quite a complicated question. Yeah, so what you could do, I'll tell you what I'm going to do. I'm going to come out of this presentation entirely and go back into it so I can do some more inking on it. That's what I want to discard that and then run it again. Right. Now, one of the things that I can do, as you know, is I can put a virtual network between stuff that I've got running in. Oh, let me do this again. I can put a virtual network between stuff that I've got running in the on-premises environment here and stuff that I've got running in the cloud, like that line of business application. So that's a virtual network that joins those two things together. It means just at this juncture here, I've got a VPN. Okay. Now, that means that this directory is connected through the VPN to some infrastructure that I have here. So let's put Active Directory domain controller here. Put an Active Directory domain controller here. And one of the other things I could put here is an Active Directory Federation Services machine. So I could have ADFS here, and I have to have an ADFS box here in order for this federation to work, because that's the thing which does this federated connection here. So the connection between Active Directory in the cloud and Active Directory on premises is this box here, ADFS, ADFS2. So the fact now that I have an ADFS server up here, which is connected to Active Directory, means it could be a backup. But I think it's kind of a moot point, really, because if I had an Active Directory domain controller here, then I almost have no need for this in the first place, because I could just integrate this application straight into Active Directory in any case. So I could do something like that. There's probably, you know, a really good architecture design session in the merits and demerits of both of these different types of ways of doing it. And a reasonable person's blog to look at around this area is a guy called Vittorio Bertocci. In fact, I'll just show you the blog entry while we're here, because I think probably this is going to spark a little bit of debate. So if you go to this blog, if you go to blogs.msdn.com/b/vb, that one there. This is a discussion point about how you provision Active Directory, how you do federation, and how you might consider all of those points that I've just been talking about. So this blog entry would probably be quite a good place for you to visit, because we're not going to have time to go through the sort of the intimate detail of all of that. Okay. Oops, I don't want to close all tabs, just want to close that tab. Right, okay. Where's Dan gone? Dan's disappeared. Okay, so we've talked about our federated trust. We've talked about how we get connected to the directory. We've talked about how the tokens move, and remember that the token is issued by Active Directory Federation Services in the on-premises environment. It hits the Windows Azure Active Directory. That issues its own token, which gets redirected to the line of business application. That application has the necessary certificate to validate the token, cracks it open, says, yep, it's all valid, and allows the user into the service.